Welcome to the AI Lyceum, a place where I explore ideas, people, and technology shaping the future of AI. For those who don't know me, I am Samraj. I'm certified as an AI ethicist through Oxethica as part of the University of Oxford programme, and I'm also a visiting lecturer at Durham University for marketing and AI. Each episode, I speak with leaders driving real change in the AI space for the world, and I ask them their thoughts on the matter. So today I'm joined by Scot Bryson, who's a general partner at Impactful Capital. He's also founder and CEO of Orbital Farm, a company using AI and automation to build self-sustaining ecosystems for the future of the planet and beyond. Reusing waste heat to heat up closed loop ecosystems from energy from data centers that grow food, energy, and medicine. Scott's work bridges sustainability, space, tech, and intelligent systems, and finance now. He's collaborated with NASA, the Climate Bonds Initiative, and multinational partners, all with one goal to make life sustainable everywhere and to ensure that this planet has recyclable energy.
Thank you so much for having me. It's a pleasure to be here, and always excited to share more on this subject and topic. I've been an entrepreneur now for 20 years, and built and founded multiple different companies, and love this discussion. Excited about the ethics part of your research and work, and would love to talk a little bit about that as well, and how we see our interaction as society together with what future AI is going to look like. I spend my time thinking 10, 20, 50 years in the future, and developing solutions to be able to fit into that. So I spend a good deal of time thinking about what that might look like when it's hard to see what the next year looks like in AI. How do you design and prepare for systems that take decades to build up and develop? So yeah, really looking forward to this conversation.
Awesome. And based on that, we might as well just kick off with ethics. So, from your point of view, what is ethics and why does it matter when it comes to AI and the way that AI's supply chain works?
Yeah, I mean, it's a big question. What is ethics? I mean, it is. I didn't prepare for this conversation, but so I don't have notes to pull from. But I feel like ethics is taking into account the ecosystem players within a thought space, or within the context of the discussion. I think it tries to understand motivations and decisions that are based upon that subset of actors or players in that discussion. And I think it tries to quantify each of the different intricacies of that entire group. And so, what I mean by that is when we think in the context of AI and ethics regarding AI, it's taking into what the AI needs and wants and thinks about. It's taking the humans and what they need and want to think about to be able to value their existence and subsistence. It's also taking into account the environment, the ecosystem in which we thrive and live within. And it's not looking at today just the plants and the trees and the animal and the flora and fauna, but it's also thinking about the longevity where what length of time are we going to be here for? And are the generations coming after us for? And so it's really taking a very wide picture, into understanding and thinking about all of these ecosystem players and taking that into your decision making on the decisions that we make today. And that helps to further clarify which decisions impact the ethics of all of those ecosystem players. It's a very 20,000 or 50,000 foot view of it, but it comes down to simple decisions of which energy source you use, and what are you going to do at the end of its life. Or when you look at a data center, it's not just the server or the way that you cool the chipset on that server, or the electrons that power that server, or even the building and the materials in it, but it's also looking at the heat that it produces, because that's part of the output, and the actual reality that is the output of the system. The system converts electricity to heat. We just derive value out of its heat. And so if you don't look at that as a part of the equation, you're ignoring the wider subset of information. And so the ethics of the choice doesn't take into account the ethics of the ecosystem that you're operating in. So that's how I look at ethics at many different levels and layers. Um, yeah.
Yeah, ethics is an interesting one because I think the most simple definition is understanding what's right and wrong. The right and wrong is based on semantics, right? And these
Right.
tools are using language to understand semantics. And basically, the whole structure of our world now is based on language because AI is a language-based tool that has mathematics in the background.
Yep.
So it's using mathematics to define language, which I find extremely interesting because we see the two as two different subjects, but really, it's maths is behind the language now. And for me, that's taken some time to get used to. Um, and I'm not an expert by any means in understanding these things, but I'm just curious. So, in terms of what you do with Orbital Farm, what why is it called Orbital Farm, and what does it do for the environment?
It's a good question. I spent a good deal of time thinking about the name originally. Um, it the name the reasoning behind the name comes from circular industrial economy and thinking about how do you build circular industrial systems, and so this is part and part of the word orbital, meaning and thinking about circular industrial systems. It also ties to orbiting from a planetary perspective, and tying back to space and the ability to operate and thrive in the space environment forces you to think in a circular way because you have to bring all of your resources with you, and you have to maintain those resources over long periods of time because you don't have caches of water that are just sitting readily available to pull from a tap and refill, or carbon, or nitrogen, or phosphorus. You have to bring all of these elements and these resources, and you have to take them, utilize them, and then recycle them and on your own. And so it forces you to think in extreme places, and it's sort of the 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 precipice of what the future of humanity ultimately holds. The ability for us to develop the capacity and capability to be able to thrive in that environment will mean that we can thrive in this environment where there is abundance of resources and availability. And so if we can aim towards that extreme area, and executing perfectly in that extreme area, it's going to make our ability to thrive here with abundance that much better, that much easier, that much more sustainable, and be able to weather the storms of the next centuries to come, that are going to happen here. So
Yeah,
there's multiple layers of what comes into the name.
yeah, it's interesting because Callum Chase, who I interviewed, who's an AI best-selling author, he coined the term the economic singularity, which you just mentioned about abundance. So when we hit abundance of everything, that'll be the economic singularity, point we can't see past. And hopefully everyone will have so much abundance that the economy is booming and we don't need to do as much work. That kind of seems aligned with what you're saying. And in terms of,
I
yeah,
think it feeds into it, but I think we're there. I mean, I live in Toronto. We have a greenhouse that's within 2 hours of here that grows banana, guava, papaya. They're starting to grow dragon fruit. Um, there's lettuce and peppers and cucumbers and tomatoes and eggplant growing in greenhouses 3 hours away from here, or even closer in some instances. We have nuclear power facilities that are carrying more than half of our grid power. We've had those for 50 years in some instances. We have, I mean, certainly in this region, we have unbelievable quantities of fresh water resources, which not many places on the planet have the excess of the Great Lakes. But we really do, by most definitions, live in a place where we do have unbelievable abundance. I just don't think we think about that in that context because of our individual actor basis, and because of the individual elements that we play in society, and these social burdens and these social barriers that inhibit us from living in that way, which I don't think we should live in an abundance mindset when operating in a large open ecosystem. We do have at a global scale, we do have a lot of scarcity. We do have a lot of scarcity of water resources and fertile soil and abundant renewable energy sources. And this lies in this it's a dichotomy, I guess, of two situations where locally and individually maybe we do live in abundance, but on a global context, on an ecosystem context, we certainly don't. Um,
Yeah, and it's important to quantify what abundance means. Is it a particular amount of something? And if so, what is that metric that we quantify to say, hey, we're abundant? Is it per person? Is it overall? It's quite important to probably define it for the world in the future. But
yeah.
outside of our world, you've
Mm.
well, inside of our world, you've been working with NASA, which focuses on outside of our world stuff. What projects have you worked on, and what has been the highlight for you?
Yeah, it's a great question. It was my work with NASA over the years and multiple different years. I think this is coming into my fifth year working together with them. Um, it's really been involved around helping to evaluate proposals and thinking about understanding on the long term, and over a variety of technologies that require multiple different technologies to be able to enable humans to thrive and live. And so I've worked with the Trish team, which is the astronaut health department. I've worked with some of their Centennial Challenges programs on large global challenges to tackle major problems. I've worked with NIAC, which is their Advanced Technologies division, and this is really about understanding how do you advance technologies that are concepts that have never been tested or proven, and maybe components but not really together with this. And the point of doing this work is to create new possibilities that today we're at this precipice point, but with the further exploration of a specific idea or possibility, it could completely revolutionize how we think about what we could achieve in the future. And where that comes, a good example of a study funded a number of years ago was the idea that we could maybe take a asteroid and convert that asteroid over time into soil, and that could be an abundant resource of soil by using a specific tailored microbes to be able to convert inorganic elements into organically and bioavailable elements that could be used, or another to be able to convert the lunar regolith and develop a massive glass blowing system to be able to build habitats and massive structures from a small technology, completely enabling new abilities for us to be able to execute in these environments, but would never get investor support, would never, there's no program that these fit into a box towards. But these ideas, from physical elements to biological elements to subsystems for water cleaning technologies and air purifying technologies to energy generation and storage to efficient thermal management systems, all of the different elements that are part of what is required to keep an astronaut alive in space. All of these elements, this is the electricity that to run the operations. It's the thermal balancing, it's the storing of that energy, it's the data center and operations and the AI systems to control and manage all of these systems and subsystems. It's the water treatment systems, it's the dehumidification, it's the CO2 removal, it's the oxygen generation, it's also which also produces hydrogen. It's the food systems, it's the food production systems, it's the waste, the human waste, the physical waste side of things. All of these systems have to work perfectly, and they have to work perfectly together in a closed system. And if one of those systems fails, the whole system collapses. And if one of those systems produces a waste product that is toxic to the others, the whole system fails. And we have 25 years of perfection. What I mean by that is the International Space Station has been continually habited people, astronauts have been there for more than 25 years continually without interruption. And certainly systems break down and certainly systems need repairing, but we have redundancies. We have backup and replacement parts. We have a schedule of replacement of these technologies. And that is the perfect system. It is an example of what an extreme environment delivers because that spills out all the technologies we need for our ecosystem here on Earth. We don't need to be as perfect as we do on the International Space Station. But we got to be better than doing nothing here that we normally do. And so that really defines, it was a very long explanation of my work at NASA, but it really defines the purpose of having that focus because it is the Formula One industry for our sustainability sector. And that really is exciting. And that really is inspirational. And we think about what do we need to do here on Earth to live in a more sustainable world. You've got to work on the positive and exciting side of the world of this equation. You've got to work in ways that inspire people because it's very scary and depressing if you think about all the negative futures and potentials. But there is a really exciting, positive future that is we are doing today, and it's really a question of our will. Do we want that exciting future, or do we want the scary, sad future? And I don't want the scary, sad future. I want the exciting future. And so I spend my time and I support and I help the scientists, the engineers, the technology companies, the investors, the citizens that care and want to live in that positive future. And I spend all of my time focused in that area. And that's how I think we get to that positive future, is spending more resources and time and support to help drive that forward. So that's my involvement with NASA. And I think it's so exciting. It's so fun.
It is really exciting. It looks like behind you you have what you think abundance looks like on that picture.
I think it's a beautiful spring or fall setting, and it's the future that we live in today, and that's the society and the future that we want to maintain and keep and create. And it really is about being grounded. It really is about being practical and realistic, but having a long future in mind and keeping that as the light at the end of the tunnel that you're driving towards. And it's really critical to think in that way. But being practical and not being some crazy dreamer thinking that all of this is potentially possible today, but coming together with practical, grounded, real plans. That's the balance that needs to be struck.
And in terms of AI,
Yeah.
how do you want us to use AI to maximize as much sustainability in the world as possible in your lifetime?
Well, I think, the example I was hinting at a little bit earlier with the waste heat, tie it back to space for a second. In space, it is super critical that you look at the entire balance of the plant, that you need computer operations to maintain and manage all the robotic systems, all the subsystems. It would be impossible for all of that to be done manually. And so the ability for us to have and use computer operations in space is critical. And they really output a significant amount of heat. They convert nearly 100% of the electricity going into heat. Now we look at this here today as waste heat, and we reject that heat by just putting radiators and ultimately evaporators to do evaporative cooling, or pumping that heat into other things is the alternative solution. And so using a data center as your heater and calculating its heat output and using temperatures from 30 degrees Celsius to 60 degrees Celsius temperatures, there's abundant capability of providing utility out of that temperature. We don't look at that context normally because we normally look at energy and its ability to use that energy to turn back into electricity or to turn that into something else that is directly usable by that same heat producing system. And so in in a cement plant, for example, you can use the waste heat to drive other processes that need lower heats. Same within steel mills. And so they optimize the heat use within the context of the product that they're delivering. But it reaches a point at which it doesn't provide utility for that individual business, and then it becomes a waste product. And so the same thing happens with servers. And the same thing happens here, where 30 degrees Celsius temperatures are a problem, and they are not usable because you're not able to convert that back to electricity. But it's abundant for our buildings. It's abundant for our greenhouses. It's abundant for our ability to be able to use heat and maintaining specific temperatures for anaerobic digestion and dealing with waste product. It's really useful in drying pulp in a paper recycling facility. It's really useful in providing heating to water source heat pump systems for our homes and our buildings. And it completely displaces the use of other energy sources, whether that's electrical or whether that's other fossil fuel sources, to be able to drive heating in those other ancillary products and businesses. And really, this is just, we should be thinking about how we design the ecosystem of our data centers, in how we co-locate other ancillary businesses around it that can drive utility towards these elements. And so this is the mindset of looking at a large closed system, is that you're drawing your boundary box in a much wider context outside of where a specific hyperscaler might think about what their AI utility really is. And that's really where I see the opportunity. We have today somewhere between 8,000 and 11,000 data centers around the world. We have maybe 100 of these examples that are using their heat. Maybe 200 at the outer limit of where we are, because of our inability to look at other languages and find integration examples that people have disclosed or talked about. And so it's so limited, but this resource is so abundant. And so where I see this significant benefit, where we want to go as forget about ethics, forget about questioning of our morality of the ecosystem and fossil fuels. If you just look at how do we improve productivity as a society, if you focus on reducing waste in a process or a system, these are the fundamental first principle basics on improving productivity, is removing waste streams. And so if you can derive value, and a data center can reduce its cooling costs and reduce its capacity factor on its evaporators, reduce its inputs of fresh water resources, and a greenhouse can reduce its burning of natural gas and its inputs and cost of energy to provide heat, and you can match those two together, you're fundamentally and first principally improving the productivity of both of those systems, meaningfully reducing the cost of food, or meaningfully producing more stable pricing on food, and meaningfully reducing the operating expenses and reducing the inefficiency in a data center. And so you develop ecosystem benefits, completely disregarding ethics, completely disregarding sustainability. And so if you work in that context, it doesn't have to be data centers. It can be material production. It can be manufacturing. It can be like, this is a first principle element. And so that's really what I think about from that standpoint on where do I see the future with AI. I see this as an integration part of our data centers and the servers that are running and operating these systems being integral to our society. And I think that this provides another level of interesting thought that I think we're not considering enough. But I think when I think about what a world of superintelligence subsisting together with us looks like, I also have some thoughts around how this could be maybe improved with this symbiotic nature of a relationship. I think that if we are going to exist with the superintelligence, that superintelligence needs to exist on servers, in data centers, and will physically be storing its memory and knowledge and be physically operating and running on these servers and data center systems. And that if, as a society, we develop and produce the capability and capacity to be able to thrive, produce our food, desalinate salt water, heat our buildings and our homes, run our businesses and operations on the rejected heat from data centers, it creates a symbiosis relationship that I think is quite interesting when considering this. And that the way that we got through another critical, I guess, moment in society when the atomic bomb was developed. This was another existential threat that we have in our history. And the way that we got through that existential threat was mutually assured destruction. What, like it or not, the ability for multiple countries to develop their own atomic weapons, and to a point where we had mutually assured destruction, that tension, which has allowed the ability for us to survive and not destroy each other, is that the best solution going forward into the future? I don't think so, but it certainly has functioned, and certainly as a bridge to whatever the best might look like. And that same tension might also be possible with our superintelligence, and our ability to thrive and survive together may create that similar type of tension between a superintelligence and our ability and need for it to continue to operate, and its need and ability for us to continue to use its rejected heat. And so there may be a very interesting tension that's built there towards a future of shared benefits together between both parties. Those are some my thoughts that spin around in my head.
No problem. A lot of interesting points, especially around heat. In some countries, we need heat to keep people hot when it's a really hot country around the equator, for example. So, in these sort of regions, how do you see data centers being recycled? Because it can't be for heat, because around the equator, everyone has got enough heat.
So that it can still be with heat. So water desalination. Around the equator, you need more fresh water. There's less freshwater resources. Water scarcity will become an increasingly larger challenge. And you can use heat to do work. There are things called absorption chillers, and that you can use heat to drive a process to produce cold. And so it's not efficient when we think of, well, how much heat do you need to put in to drive a certain amount of cold? But when you're comparing the negative efficiency of evaporating water to a low efficiency of converting heat into cooling resources, it is still a plus on that scale. And the quantity and the scale of our data centers today produce a meaningful quantity and size of heat. Like, we're building gigawatt data centers. That is a gigawatt of heat every hour. Every hour these data centers are designed in business models that operate between 60 and 90% capacity factors. So you are producing 600 to 900 megawatts and peak capacity at 1,000 megawatts of heat every single hour, every day. And these data centers aren't shutting off. You may change out the servers and put more efficient, faster servers in. They're not stopping. We're not destroying them and converting them into farmland. And so these are perpetual heaters. And if that is completely wasted and extractive to our freshwater resources. And so this is where you can even work to things like, there's low temperature water desalination, where you have a vacuum chamber and you can use low temperature of water in a vacuum to evaporate that water and move from one vacuum chamber with a salty water concentration to the distilled water in another column with very little energy input. And you can just use the height of columns to be able to drive some of these processes. This is existing today. I'm not inventing anything new. This is just one example of an approach that can be done. But you have to think about these things. And that's the problem, that when you site and design a data center, you don't think about these things, because there's no forcing function to drive that. There's no forcing function to put that in. And this is what we've got to be able to do as a society. We have to demand this of the businesses that want to operate in our communities. They should be providing ecosystem benefits. They have the possibility to do that. But we as a society also can't put all of this burden on companies to get into ancillary businesses that they aren't in and won't be really good at executing in. This is where you need to build coalitions. This is where you need to bring investors to the table that can see the ecosystem benefits, that value those ecosystem benefits, and specifically finance the engineering studies to evaluate what is possible. Because it is going to be different at the equator than it is going to be here in Toronto, than it is going to be up in Sweden. And that it's not a one size fits all solution. And there are hundreds of examples of utility that can be derived at 30 to 60 degrees Celsius heats. And you can move heat from those temperatures up to 115 Celsius. And there's even technologies I know of that are in research and development that are going to be able to move that heat to 140 degrees Celsius with industrial heat pumps. So we've got the ability to be able to do this work and move those temperatures anywhere from that up to 140 Celsius all the way down to direct use of the heat at 30 Celsius. So it's just a matter of, we don't need a significant amount of invention. We need will, and we need investors to step up to the table to finance the studies to evaluate what the possibilities are. That's exciting. Honestly, it's coming to this conclusion, knowing my work with NASA and knowing my work and understanding how to catalyze and inventing new technologies. That takes a decade to invent a new technology to get it to scale. But when solutions we have abundantly available to us, and is really a question of will, and do we want to do these things? This is super exciting because this brings it back to the grounded reality of like, what can we implement today? And that isn't a long future idea. That's a, what do we do today, and where are the best places to execute first? And that's the reality side of this that's exciting.
Yeah, I think a lot of people don't really know what to do today, but I think you could come up with a solution. So I've got an example for you, or a circumstance. So imagine you're leading the world. What are the key things that you would do straight away to make it more sustainable for using AI, and also plugging AI into it, and just generally for the world in terms of data centers, reusing energy, etc.?
I mean, I don't know what it would look like if I'm leading the world, and I'm not sure I want to spend too many cycles thinking about that ungrounded reality. First off, I don't want to be a politician. I think that comes with many other challenges. But I think maybe I'll point to an example of what I think is something that is good. I think Germany is approaching this challenge from a stick standpoint, and they are mandating that new data centers that are being built are requiring to share their heat, beginning new data centers being built next year, at 10% of their heat they need to share. And then it's 2027, 15%, 2028, 20%. And so this is the stick approach to policy work that then mandates the requirement for these data centers to begin to look into the solutions. And that stick approach definitely functions. And it creates a driving force. But the other side that's really important towards this is the carrot approach. And I think the carrot approach is always the stronger, more broad-reaching impact that's possible. And the carrot approach looks like the ability to finance or provide lower cost financing to data centers. And what that means is that if you, as a data center owner and operator, if you provide and bake into your business model that you are going to share your heat, and at a certain percentage or threshold, and into utility businesses that it makes sense, and that you're deriving your electrons from non-emitting sources, that you're going to be able to access cheaper capital than everybody else. And that provides a competitive advantage that saves dollars on an annual basis on interest payments, that creates the incentive alignment that can be executed regardless of political party in the current flavor in that country, regardless of election cycles and different countries and jurisdictions. And it really provides that incentive towards aligning the work and the investment needed to make these solutions possible, and the direct benefit to working in a capitalism society where there are realities, and data center operations are billions of dollars per facility just for the building envelope and the energy components of these facilities, let alone the servers and the systems to operate it. And so if I not if what I am actively working on is a solution to do just this, to look and value the sustainable data centers and provide a framework in things like sustainable linked bonds or sustainable linked debt or green bonds, and be able to create a certification for what a sustainable data center is and looks like, and be able to create a financial mechanism to be able to allow them to access lower cost capital. And we should want this as a society because it means you get job creation, you get more local investment, you get maybe cheaper food, you get maybe cleaner water, you get maybe more local recycling capabilities and capacities, you get thermal networks that power your homes and your businesses and produce a magnet to attract businesses that can access lower cost heating for their buildings and their facilities around the communities that we want to thrive and live in. And so this is the incentive alignment work that I'm actively doing today, not in some theoretical future, and bringing together people to work on this, because that's how I think we implement change. That, I think, creates these thousands of potential locations that spreads this opportunity around to tens of thousands of people to be able to implement these solutions, because that's what it's going to take. So that's not an exact answer to your question, but that's what I'm working on.
It's a good enough answer, and you work at your general partner at Impactful Capital, right? So that's kind of the aim, is to help data centers get a stamp of approval and know where to invest. So if I was, let's say I was leading Google, Amazon, Microsoft, imagine if I was the CEO of every single tech company.
Sure.
What would you tell me to do right now with you?
I would say that you should look at your entire portfolio of your data centers that you have today and your entire portfolio of your future data centers that you're building tomorrow, and that you should be doing studies right now to best understand what the practical implementation is and the utilization of all of the heat that they're producing. And I think that you should have a plan for each one of those facilities. And that is a profound amount of work. And that's a profound amount of dollars in order to invest in that. But that's the work that we need to do. I think that if you don't do that work, I think that society is going to come and curtail you. I think that of the things that is receiving negative feedback in the news and the press today, aside from politicians, are the data centers. And I think that one of the big inhibitors to scale and growth that Bitcoin saw back almost a decade ago was the understanding of the quantity of energy that it was going to consume, and that there were fears that were driven up in terms of it's going to consume all the energy in the world if we let this get out of hand. And I think that AI is going to fall into that same bucket, when the reality could be that these are profoundly driving the sustainability agenda. They're profoundly driving real, actual impacts to people in their lives immediately, not in some far future that we have to build fear around, but actually can improve the cost and can actually improve the livelihood, can actually produce jobs. What the other thing that I would say to all the hyperscalers is that they're already aligned with this. They already have zero water commitments. They already have zero carbon commitments by 2030. That's 4 years from now. And so the challenge is the number of data center developers and the pace and the speed that we're trying to develop these facilities towards, that really becomes a major issue of how do you balance the speed of deployment with the sustainable investments that are needed? Um, and there's a tension there, no doubt there's a tension there. But I think it's a profoundly important one to focus on. And I think that there's an abundance of opportunities around. And I think that it creates the really exciting future that we want. Certainly the communities that I want to live in, that would be great. If we have a local farmers market and a local food production, and then also low cost heating for our homes and our businesses. I mean, that literally is the community I would love to be living in. And so where is that? Because I would like to find it. Um,
I would
and I
love that
think
as
that
well.
right. I think that's a pretty universal thing. And look, the other thing I will say, who's the who's the got the most potential in the future for the companies and businesses? It's the hyperscalers. It's the companies that are running our digital infrastructure. This is really the highest valuation entities on our planet. If they can't do this, nobody can. And so they can do this and they can catalyze it. They don't need to finance the whole thing. This is the other dichotomy that I think it's not just in the AI data center world. It's not just in the digital technology world. It's in every company through the lens of procurement and choosing what you buy, whether you're buying a data center to lease and own that facility, whether you're buying electricity to power your manufacturing facility, whether you're producing a waste product and choosing where that goes to, whether you're a food manufacturer and the ingredients that you're choosing to procure. What historically we have looked at these challenges is that we, as that company, have to finance all of those things. That we have to design the ideal solution, that we have to choose the perfect technology, that we have to invest hundreds of millions or maybe billions of dollars of capital needed to produce that product, that we have to take on this challenge all to ourselves. And this is the misconception. We don't. There are plenty of structures and business models that allow other investors to finance these solutions. The power purchase agreement, I think, is the most profound example of what's called an advance purchase contract. I agree to buy some electricity from this company that says it's going to produce electricity from solar panels or from wind or from hydro or from geothermal or from nuclear, whatever choice that you want to make. I agree to buy that electricity for the next 25 years at this price. It's going to go up by 1% per year for the next 25 years. Here's the contract. That cost me nothing. I didn't put a dollar. I mean, I put some money into some lawyers to sign some contracts, but there's templates already that are available for it. So it's not that much money. But what it creates is an ability for an IBM to write that contract to then give to another company. And that company now has a payment schedule from IBM, high credit worthy entity. I can now go to the bank and be like, hey, or I can go to an investment firm and say, hey, please give me a loan. I've got this contract from IBM. They're going to pay their power bill because it's pretty important for their business. And they're pretty credit worthy and they're going to be around for the next 25 years. I need to buy a bunch of solar panels to be able to produce this. And so that creates the certainty that someone's going to pay that bill. And when I buy that expensive thing, I'm going to get a loan for a lower interest rate to be able to produce that electricity. And I'm going to deliver those electrons to IBM. And everyone is happy. And that's catalyzed a new renewable energy project. It's created an investable asset that other investors trust and want to pour billions and trillions of dollars into. But IBM didn't have to pay anything. And that they are buying their electricity from that customer. And so it creates a certain amount of lock-in. But this idea of an advanced purchase contract is transferable to many different types of things. It could be green cement. It could be green steel. It could be green chemicals. It could be ingredients of food products that are going into your packaged food product. It could be the heat going into your building. It could be cooling for a data center. It is transferable to many other different things. And it means that we can create high ambition to live in a more sustainable world, but don't have to carry the financial burden, don't have to make the decision with our board of directors to say, well, do we want to do a dividend this year, guys? because we had a pretty good year, or do we want to invest in our sustainable supply chain? And making that tension, removing that tension, allowing you to say, yep, this is what we want to do, this is the product we're buying today. If someone can come in and produce this product in a more sustainable way, we're all in, and here's a potential contract. That enables profound transformation, that enables other investors to come in and finance the solutions, that enables technologies to develop into solutions that maybe there isn't one available today. Maybe this is something that we don't have an ability to produce a product at this price, at this volume, in this location. And maybe that does mean that we need some new innovation to happen there, but we don't see that. We don't know that because of the friction and because of the way that we currently procure and because the way that companies don't think that other investors or technologies can solve these problems. So that's the other big change.
Yeah, I think to know the future of the world and to structure it right now for the next 20 years is quite difficult to imagine. But there are lots of investments. And there was a recent article which I read on LinkedIn from Demis Hassabis, which is on arxiv.org. And it said Google processed 1.3 quadrillion tokens last month, which is 500 million tokens a second. Basically 500 million words for those listening a second. So imagine 500 million words in a book that's been processed every second. So 500 million words in a book processed every second. And that's equivalent to 5 times more the energy than the second biggest UK city, which is Birmingham. And that's 367,000 tons of CO2 per month. And so Gemini has 350 million monthly users. That's around 5 to 10 cities more every month, which is incredible. So there's a really interesting paper called Measuring the Environmental Impact of Delivering AI on Google Scale. And actually, to support that, Google has now written an article on Think with Google, which you'll find quite interesting, Scott. It's around making sure that there's carbon emissions reporting in advertising. So there's a call for the European Union to be more sophisticated and data-driven in their approach in measuring emissions, right? The European Union is calling businesses to do that. And customer sentiment is shifting. So it says 4 in 10 European consumers occasionally or regularly think about sustainability and climate change when shopping. So it talks about all of this, and then it says, as digital advertising stakeholders continue to consider their environmental impact, we're seeing increasing signs of maturity across the ecosystem. That's from Dimitri Bay, who I know from IB Europe. And it's just fascinating how these companies are making their own protocols. So I see every company in the world having these sort of protocols across all of their technology suites and across the AI supply chain. So I'm not sure if you saw that article, but
I
it's a really
didn't,
interesting one.
but I would love to read that. That sounds super.
Yeah, I'll send it to you for sure. But I think we're almost at time, so I'll ask you the last question. The last
Yeah.
question is from me to you to ask the audience a question to answer in the YouTube comments or wherever they see this podcast or listen to it. So, what's your question for the audience?
What is my question for the audience? I think I'm gonna go back to the last element that I was just describing. I think the profound ability to be able to finance new sustainable solutions hinges on customer interest. And what I mean by that is those procurement, that advanced purchase contract for sustainable data services for your company, the ingredients for your company. I think that the individual personal action is really important, what you do in your life and how you're choosing it. But it's really not going to move the needle in a short time frame. And every individual action helps. Picking up the piece of garbage on your walk home and throwing it into a trash bin helps. But when you're on your way to work and you go to work and you change how your company that you work at procures sustainable products, when you can make that change, that has exponentially more impact. and the scale of that impact is profound. And so, what I would ask from the audience is, where are those places that you can think in your company or your business that could be helping to drive a more sustainable future? What are those places that you see as near term wins and opportunities? Because time is so critical in this equation. Time meaning what we can implement next year, what we can implement over the next 16, 18, 24 months. This is so critical because and so what I would ask the audience to do is to think about that and maybe suggest to others and be open about that. You don't have to say exactly where you're working, but talk about the types of things that you could see that working from, and inspire others to think about their businesses and their operations and how they could help support this type of future. And I think sharing other elements that are inspirational, because it's very easy to fall into the fear traps and very easy to fall into the doom and gloom of situations. But it's really the inspirational elements that's really what drives action. And so sharing those and sharing and inspiring others by suggesting, here's a way within the companies that I work with that I could see profound change happening. And that's what I would ask people to share.
Yeah, profound point. For me personally, I think I use a hybrid car. So I see that as being less polluting for the environment. And so
Sure.
that's my change. I think another change could be having solar panels on the roof of a house. But again, it's very costly. So I think cost is a barrier for people to implement all of these changes. And it could also be, the intrusion of having these pipelines that have data centers feeding into people's houses with heat. How does that operationally work? And the infrastructure has to change totally,
But
you know?
but think about the universities that you're at, right? So the university has an endowment. That endowment has probably billions of dollars that it directs towards. You might not know today the person that works at your university endowment, but it wouldn't be that hard for you to find that contact of that person, send them an email, and talk to them, and see what support do they need. Are they investing in sustainable technologies? Are they deploying capital to, if you care about solar residential or residential solar for homes in your community, are they supporting that? And so what are they doing? How is the university procuring its electricity? And digging in and asking that question. And so that impact that you're going to be able to have because of your individual network, because of your position as a professor, as a position as a researcher there, it allows you access to those communities, and you can instill behavior change at that level, which is way more profound than driving your hybrid car, which I think is great, and I don't want to dissuade you from that element. But think of the impact difference between the university scale and your home and your individual action. And that's the change that I want to empower you with. And I want to empower all the other listeners with thinking through that process with the other influence that they have at an organization level. Because then
It's
it's
a
not
great
your
point.
cost. This is a great type of investment for an endowment. This is a great type of investment for a university. This is how they attract better students. It's something they can add to their marketing and their that, hey, we're powered by green energy or renewable energy, or hey, our portfolio of our investment is invested in elements and loaning our capital out to more sustainable technologies and solutions versus more fossil fuel companies. And if you don't spend time thinking about it, if you don't spend time focusing on it, if you don't spend time measuring it, it's not going to happen.
For sure. Well, thank you very much for your answer. I think there's a lot to think about. There's so much information that we've been talking about today. Lots of new topics for a lot of people. And I'd love to hear everyone's comments around what they think to Scott's question. And just want to say thanks, Scott, for your time and for your energy and for all of your knowledge, because knowledge is key to making change in this sustainable era, for sure.
Awesome. Well, thank you very much for having me. I'm always happy to answer other direct questions or do follow up. But yeah, really appreciate the time today.